Hello. Uh, I wanted to show you guys how to export the velocity data for the 2D and 3D analysis um, with CFD. So we're going to start, we can call this one the 2D. And we'll go in here and change the properties to 2D and open up Design Modeler. Down here, what I like to do is draw on the XY plane. If you right click and say look at, you can look at that view. And then the other thing I'll do is, since we know that the sketch is only 3 meters long, you can use this graph here to zoom in, so you don't have to do so many so you don't have such a large deviation when you go to do your dimensioning. So anyway, so in this view, we'll go to sketching, and we're just going to make a simple rectangle. It's nothing too major. If you look at the bottom right corner, you can actually see your X and Y dimensions, and you can kind of guesstimate where things are going to be, but it's not important to get it perfect the first time. So once you draw your rectangle, you're going to go to dimensions. You can leave it in general, and I'm going to zoom in here, and in general, click that one and that one, so we know that it's 0.1 in diameter and 3 meters long. Now from here, what we're going to do is go to concepts, and we're going to go sketch from edges. Again, that was I'm sorry, surface from sketches, excuse me. And hold the control key, and you're going to select each line that was created with the rectangle. Once that's done, you'll see that all your lines are this lighter blue color if you generate, and it'll create that surface. So the other thing we need to do is we need to change it from a solid boundary to a fluid domain, because ANSYS is both a FEA and CFD. You have to tell it what kind of material it is. So that's all we have to do in here. We'll go ahead and close this out, and we're going to open up the mesh. You can double click it or hit right click and then edit. So now that this is open, what we're going to do is we're going to create some of these mesh controls. So when you highlight mesh control, we're going to go to sizing and make sure that you select the edge. We do the inlet and outlet areas, hit apply, and we're going to change that type to number of divisions. I think he used 20. I think maybe 10. We'll just use 10. I don't want this to take forever. We'll do the same thing for these two lines. We would, again, hold control. You can select two lines at once instead of having to do it twice, and we'll do that. Select number of divisions. We're going to go 100. And the other thing we'll do is we'll do a face meshing, and when you do that, it automatically selects the face tool. So we'll select the face, hit apply, and then we'll update our mesh. And you can click on the mesh, and that's what it looks like. But sometimes this happens, and this happens a lot for me. I don't know why it does this, but you can see here it actually gives it a huge thickness, and we're doing a 2D analysis, so we don't need any thickness. So if you click on this and then the surface body, it actually says thickness, so we're going to give it 0 and change it back to 0 when you go back to your mesh. Now it has no thickness. So from here, what I want to do is I think it's okay. You can change that first edge sizing probably to 20, and it probably will look a little better. So there you go. That looks a little better in the inlet, and this would be your outlet mesh. So now what we'll do next is we'll set our boundaries using first this edge tool again, and if you click on that edge, and you can click anywhere else inside of this kind of blue square here and right click and say create name selection. So we're going to call this the inlet. Do the same thing for this one, which is your outlet. Create name selection outlet. This is handy if you name things properly and give them the correct name. When you go into Fluent, the CFD simulation, it'll actually recognize these names and give it the correct boundaries. So this top one is our wall. This one here is going to be called center line. And then the last one we want to do, we want to go to the face selection. We're going to select this face, and then we're going to give this the fluid, and that'll recognize that as the fluid domain. So now we are done in here. We can close this out. And from here, what you want to do is tell it to update again, and it's going to go ahead and update the mesh. So here we're going to go ahead and tell it to edit. We want to do double precision. It automatically detects that we're doing a 2D analysis. And what I like to do is go into parallel here, and I have 4 processors. You'll have to see about your computer about how many processors it has. A lot of computers now are quad core, so this just helps speed up any kind of simulation processes. So we hit OK. It's going to open up Fluent. This may take a little bit. Alright, so the first thing we want to do is hit this check, and all it does is just check to make sure that the mesh is actually done properly and there's no errors in the mesh. So since we're doing half the pipe wall, or half the diameter of the pipe, we're going to do a asymmetric space. And basically what that defines is that this wall, this line here, is actually the center line and not necessarily this being one pipe. It lets it know that it's 1/2 the diameter when we go to set the boundary conditions. So what we want to do now is we want to create a new fluid, and what he did for this one, and I'm just going to call it fluid, it was a density of 1 kilogram per meter cubed, and the viscosity was 0.002 if I'm not mistaken. So we're just going to go ahead and create it. It's going to tell you it's going to override it. It's okay. So now we're done. You can close that out. And here we have our fluid that we just created. So in our cell zones, here's our fluid, and what we want to do is make sure that it has selected fluid, and you can double check that by hitting edit, and you see it's the same properties we gave just a second ago. So in our boundary conditions, the only one that it won't recognize the name is center line, so we'll select a center line, and then we're going to go in here and change that to an axis, and it just changes the name. You just said OK, and now it's an X. It sets it as the axis instead of the wall. The next thing we want to do is do our inlet. If you double click it, we can do components, and we're going to set this to an axial velocity of 1 and hit OK, and make sure that our operating conditions are within the atmospheric pressure. We're going to do the same thing for our outlet. Make sure it's a pressure outlet. Double click on it and make sure the gauge pressure is 0, of course, because it's outlet into the atmosphere, so it has a 0 gauge pressure. Now the next thing we want to do is go to our monitors and residuals, and we're going to change this to be I think 0.0001. I'm going to move 1, and this is just a boundary for the iterations. So as it does its iterations, if it finds a difference greater than these numbers as it runs through them, it'll keep running iterations until it either reaches this limit or it reaches this criteria we've set. Now the next thing we're going to do is we're going to go to initialization, and we're going to change this to a standard initialization, and our axial velocity initially is 1 meter per second, and we're going to tell it to initialize, and sometimes you have to hit it twice, I don't know why. So once this patch comes up as a selectable item, I've noticed that that's when it actually does it correctly. Sometimes it doesn't do it all the time. So we're going to go to run calculations, and we're going to change our number of iterations to, for this one I'm going to do, it says to do 1,000, I'm going to do probably 500. I just don't want it to run forever, so all you have to do now is hit calculate, and it's going to run through these iterations. And we've set this monitor residuals, so as it's calculating, it's going to show us the graph of the residuals that it's getting from the x and y velocity, especially and the continuity. So now you see we have our continuity, which is the boundaries reset. So it actually found continuity a lot quicker than the 500 iterations that I set for it. So what we'll do to get the velocity plot is we'll go to here, plots, in XY plots, and we'll say edit. What we want to do is we want to do a velocity, the velocity magnitude, and direction, and we want to set it to the center line. The center line is going to be the best place to get your velocity. Is if you do something like the wall, of course, because we've set a no slip condition, there should be no velocity there. So you can plot it, and this will show you the graph of your velocity. So it starts out at 1, which is what we said initially, and it's going to grow as it reaches the exit, and that's due to the energy balance. We're going from one pressure to another pressure, and the secondary pressure at the exit is actually lower than the inlet pressure, so that pressure differential causes the fluid to speed up. So the exiting pressure is higher than the the exit velocity is higher than the inlet velocity. So we can actually set this and export this out to Excel by telling it, clicking this write to files and order points. All this does is it orders the points from 0.00 all the way to 3.0. If you don't do that, it kind of scrambles them up sometimes. And all you have to do is hit write, and what I'm going to do is just put it here in this thing, and I'm going to call it 2D velocity, and hit OK. And you saw a little pop-up. It was very quick, and then we're done. So I'm going to go in here and go here, and the other thing you want to do, is what you can do is just open up Excel, just do a blank one, and then go to File, Open. I'm going to go to my computer, Browse, and make sure you select all files, and then from there you can select the 2D velocity. And it saves it as like a dot XY, but Excel can read what's written in there once you just tell it to open, and just say yes. And you don't really have to mess with anything in here, and just say finish. And now what we have here is this plot here is your X position in meters, and this is your velocity. So what I'm going to do is highlight all of this and just say insert, and you can go here to charts, lines, whatever, and there's your graph. And if you click on this, you can say format axis, select data, right click, select data. So the horizontal axis is our X position from 0 to 3 meters, and we want to edit that. And what you can do is just select this line or this column of data and hit OK, and then it changes this to be what the heck did I do there? Didn't want to work, so let me try this again. So I'm going to select that, say OK, OK, now OK. So now it's just changed this this horizontal axis to be your position from 0 to 3 meters. These numbers here are very, I have a lot of residuals down at the low end, so what you can do is just highlight that whole column, say format cells, call it a number, and just give it decimal places of 2, and that'll get you a better looking horizontal axis. And then you can also you can edit all these this vertical axis as well. You can set the minimum to be we started out at 1, so you can do like 0.8, and we know it goes up to 2, so we can do like 2.1, and it just makes it a better looking graph. But you can see that as it exits, the velocity increases, but at some point it's almost a net difference where they're almost there's little to no change after about halfway through. So this is just the first part. I'm going to make a second video to show you how to do it in 3D. Thank you.